Hello, welcome to another video, mechanics, vectors and things at different angles and seeing what happens with the resultant. In this question, which I believe is question 4 of the series that we're doing here, we have 3 forces. So a little bit, just when you thought it couldn't get any more fun, the third force comes along. We have P, Q and R, 3 forces, and they act on a particle in the plane of the coordinate axis is OX and OY. So that sounds all a bit weird, but it just means this. You've got OX and OY, and the 3 forces act here. This might be a bit too small eventually, but we'll see how it goes. And what are we told? We're told that force P acts along OX. So force P is going to act along here, OX. Force Q acts along OY, which is this one here. And R acts at an angle theta with OX. So R is going to be somewhere here in the middle, and P is going to be here, and Q is going to be along here in the first quadrant. So yeah, so R is going to be in the first quadrant. Now calculate the magnitude of the resultant force. This is the first quadrant here, by the way. That's the first quadrant. Calculate the magnitude of the resultant force and the angle it makes with OX when these 3 forces are acting. So let's see what they throw at us. Let's do this part. So 5, 6 and 7. So P is 5. Let's say that that's P. And Q is 6. So Q is going to be a little bit longer. Going to be here. It's going to be 6. Q. So magnitude 5, magnitude 6, and R is magnitude 7 at 45 degrees. So this is 45 degrees, something like that, and it's a little bit longer than the others. R, because it's 7. So now we have 3 forces acting, these 3, and we don't know what direction the resultant is going to be. So my recommendation in order to add these guys is first to add 2 of them and get the resultant, and then add the third one, basically. That would be quite long to do. So I'm actually going to recommend different, which would be much quicker. If we resolve this R guy, since we know that this is 45 degrees, so just for the record, what I'd said before, which was a bit silly, would have been to add P first, so that's P, and add Q, right, so that's Q. So we add P to Q, and then we get something like this guy. And now this guy, we have to add it to R. I don't know if it's going to be below or above, but imagine it's below. Then R is this guy. And now we need to add these 2 with a really awkward angle here. We don't know what that angle is. And we've got to add it using the sine rule and the cosine rule. And that would be a mission. So we're going to try to avoid that. And this is why resolving in different directions is really useful. Let's ignore P and Q for the moment. Just knowing that P is along there and Q is along there. Why don't we see how much of R is in the direction of P and how much of R is in the direction of Q, and when we know that, we can then add the resultant R in this direction to P in a line. So if P is 5 and the resultant of R along this direction is 2, or it's going to be a bit bigger, but if it was 2, then we just do 2 plus 5, that would be 7, and we'd have a new kind of a longer P due to R. And the same thing along Q. If the shadow of this guy on there is 3, then we add the 3 to the 6, and we can do a longer one here. And then we can add these 2, P and Q, forgetting about R, which we've already taken into account, in a Pythagorean triangle. Right? So that's what we'll do. So let's see. R is 7, they told us. 7 newtons. So let's find out how much of R is in this direction. Well, since it's the adjacent, you should know from SOHCAHTOA that whenever you're dealing with the adjacent and the hypotenuse, like we are now, we've got the long one here, which is 7, and we want to know how much of that 7 is along the adjacent. Then adjacent hypotenuse, we want to use cos. So r times the cos, so I'm just going to do the first one like this, and all the other ones I'll do it normally. So then cos of 45 is equal to the adjacent over hypotenuse, so that's the x component of r, which I'm going to call rx, divided by the hypotenuse, which is r, the full r. So what we're interested in, which is the rx, would then be, we multiply r both sides, we get r cos 45, that's equal to the rx that we're interested in, and since r is 7, then 7 cos 45 is going to equal rx, and 7 times cos of 45 is equal to 4.9497, so 4.9497. And if we need to use this answer again, we need to use the full answer. So I'm going to store that in my memory by pressing Shift Store A. And if I want to recall it, I press Recall A. That's using the button RCL on the bottom left of your fancy key section on the calculator. You should have a button that says RCL, and if you press Shift RCL, then it presses Store, and then you choose the letter from the A, B, C, D, E, F on top, and it should store it there when you press Execute. And then we can recall it for the next parts of the question, and we won't lose any accuracy. So now we know the magnitude of Rx is 4.9497, something like that, so that's pretty close to 5 newtons along here. So let's calculate the new P. If the old P was 5, the new P is going to be those 5 plus the part of this R which is helping P along that direction. So that answer there, press answer plus the 7 of plus the so minus 7 plus the original 5 of the P, we're going to get something closer to 10. So it's 5 plus something near to 5. So our new P, so our P plus Rx basically is what we've done. P plus Rx is to our vectors. The magnitude of P plus Rx is going to be equal to 9.94 is what it came out for me, 9.94, and then 97, etc. So that's the new, which I'm going to now store. Nine, 497. Okay, so now we've done that, and let's do it on the other side. On the Q side, we want the R on the side of Y. So R on the side of Y, and since that's the opposite here, it's the same as this, so we're finding out this side, then that's the opposite, and the hypotenuse, so that's sine opposite hypotenuse, that's the sine, so that's equal to the full R times the sine of 45. So same as here, it was the full R times the cos of 45, and this is the full R here. So our Ry that we're looking for will be the full size, which is 7 times the sine of 45. Actually, since this is 45 degrees, these are going to be the same size, so we're going to get again 4.9497, etc. right? It's the same because it's 45 degrees chops the square in half. So here we're going to add that to plus the Q, which is originally 6, so we're gonna get 10.9497 blah blah blah. So that's R Y newtons. So now we have sorry, that's not Ry, that's Q plus Ry, magnitude of Q plus Ry, and we know that the directions are those two, so we can say, okay, something in this direction with magnitude 9.9497, and something in this direction with magnitude 11, sorry, 10.9497. It's gonna have a resultant in yellow, because we like yellow for resultants. And we can do then r squared is equal to one of the decimals squared plus the other decimal squared. So r is equal to the square root of those two guys, which works out to answer squared plus the memory from before squared, and the square root of that is 14.795 blah blah blah, so that's 14.8 newtons is the magnitude of my resultant, this guy, 14.8 newtons. And now if we want to find the angle here that we're also asked for, then we need to do opposite over adjacent, for example, and that's tan of theta is equal to 10.94 blah 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 divided by 9.94 blah blah blah, and then theta is the inverse tan of that fraction, and that works out to be, let's see, 10. Shift tan of the answer 47.7 degrees, and that's alright, that makes sense because it's somewhere here, so it's a little bit more than 45. So when you add these two, it comes out to a little bit more than 45. That's the resultant of the three forces, and that makes sense because Q is a little bit bigger than P, so it makes sense that it draws R, which was here right smack in the middle. It draws it a little bit that way when you've added them. Okay, so what we've done really there, it's a bit funny because we've done this force plus this is P, and we've added to that a force that looked like that, Q, it's a bit longer than P, and then another force that was like that at 45 degrees, that was R. Oops, was it R? Yeah, it was R. Sorry, I should have used a different letter here for this R. Let's call it R. I don't know what to call it. R star. The different R, the overall R. So I should have used a different letter there. Sorry. So that's R star squared. That's R star. Let's say we had three forces, and one of them already was called R, so I shouldn't have called my resultant R. Anyway, so we've got P, Q, and R, and so what we've done is added them. So we added this one, and then add that one, which was, sorry, then added Q like that, and then added R, and R was like that, 45. So really, our final resultant is kind of would look like I don't know, it would look like something like that. When you've added the three of them, this one's like that, that was like that, and that was like that. Then our final one looks like something like that. So it came out to be 14 newtons, right? So it's quite long. If R was only 7 newtons big, then our final resultant came out to 14 newtons. So that's, it's nearly twice as much, which makes sense because we've added them like that, right? We add something like that plus that, and you get something nearly twice as big. All right, so that makes sense, and hopefully that's doesn't completely confuse you too much. And yeah, we'll see you in the next video for the next example. All right, take care.